Hello everyone. Welcome to today's video presentation. I will be sharing to you an interesting technique used in advanced ceramics. In this presentation, we'll be diving into electrophoretic deposition technique. Whether you're a beginner looking to learn more about this subject or an experienced enthusiast seeking new insights, I believe you'll find value in the information I'm about to share. Throughout this video, we'll explore what electrophoretic deposition is, its brief history, industrial applications, its synthesis process, material characterization, and properties. Electrophoretic deposition, EPD, is a process used to deposit particles or colloids onto a solid substrate under the influence of an electric field.
It is a widely employed technique in materials science and engineering for the fabrication of thin films, coatings, and composites. The basic principle of electrophoretic deposition involves suspending particles in a liquid medium, usually a solvent or an aqueous solution, and applying an electric field across the suspension. The electrophoretic deposition technique, which has a wide range of novel applications in the processing of advanced ceramic materials and coatings, has recently gained increasing interest both in academia and in the industrial sector, not only because of its high versatility in use with different materials and their combinations, but also because of its low cost due to the use of simple apparatus. The phenomenon of electrophoresis has been known since the beginning of the 19th century, and it has found application in the past 40 years mainly in traditional ceramic technology. Since 1808, when Russian scientist Rus observed an electric field-induced movement of clay particles in water, electrophoretic deposition, EPD, has been known. However, the first practical application of the techniques was in 1933. Although the basic phenomena involved in EPD are well understood and have been the subject of extensive theoretical and experimental research, Hamaker was the first to study the process, and it wasn't until the 1980s that the process received attention in the field of advanced ceramics. The versatility of EPD allows it to be applied in a wide range of industries and contributes to the development of advanced materials and functional coatings. EPD has numerous industrial applications across various sectors such as automotive industry, electronics and semiconductor industry, energy storage and conversion, ceramics and coatings, and biomedical applications. The microstructure and chemical composition of a material used in EPD can vary depending on factors such as the material itself, the processing conditions, and any subsequent treatments applied after deposition. These factors can be tailored to achieve desired properties and performance in the resulting coating. The microstructure of coatings obtained through EPD can vary depending on factors such as the deposition parameters, particle size, and processing conditions. The synthesis process of EPD involves several key steps, from preparation of the suspension, selection of electrolyte, electrode preparation, electrolyte configuration, application of electric field, particle deposition, and post-deposition treatments. It is important to note that the specific details of the EPD synthesis process can vary depending on the material being deposited, the desired coating properties, and the equipment used. Material characterization techniques are crucial in understanding the properties and performance of materials fabricated using EPD. It involves scanning electron microscope, X-ray diffraction, transmission electron microscope, energy dispersive X-ray spectroscopy, atomic force microscope, and Fourier transform infrared spectroscopy. Electrophoretic deposition is a versatile and powerful technique that offers numerous advantages for the deposition of materials on various surfaces. Some properties involved adhesion, efficiency, environmental friendliness, homogeneity, flexibility, and selectivity. Electrophoretic deposition, EPD, continues to be an active area of research with numerous ongoing studies. Here are a few current research topics and applications that utilize EPD. The versatility and wide range of applications of EPD continue to drive ongoing research efforts in academia, industry, and research institutions to explore new materials, deposition techniques, and applications for EPD. The annual cost of production for EPD can vary widely depending on several factors such as the type of material being deposited, the size and complexity of the substrate, the scale of production, the cost of raw materials, the energy consumption, and the labor costs. However, it is worth noting that EPD is generally considered a cost-effective and environmentally friendly technique compared to other deposition methods such as vapor deposition, especially for large-scale production.